The James Webb Space Telescope is finally in operation, and scientists have not been disappointed. The powerful telescope continues to deliver stunning images that challenge everything we thought we knew about space. In this video, we bring you James Webb Space Telescope's 15 all-new images that shook the entire space industry. And number 1 is the image that revealed the glittering landscape of starbirth. Where do stars come from? Some of us wondered as curious little kids before adulthood replaced such thoughts with more pressing ones. However, the James Webb Space Telescope is finally providing an answer with one of its most spectacular images ever. This landscape of mountains and valleys speckled with glittering stars is actually the edge of the Carina Nebula's nearby young star-forming region known as NGC 3324. This image, captured in infrared light by NASA's new James Webb Space Telescope, reveals previously invisible areas of starbirth for the first time. JWST's three-dimensional image, titled The Cosmic Cliffs, resembles craggy mountains on a moonlit evening. In reality, it is the edge of NGC 3324's massive gaseous cavity, and the tallest peaks in this image are about 7 light-years high. The intense ultraviolet radiation and stellar winds from extremely massive hot young stars located in the center of the bubble above the nebula carved out the cavernous area you see in the photo. The young star's blistering ultraviolet radiation is sculpting the nebula's wall by slowly eroding it away. Resisting this radiation are dramatic pillars that tower above the glowing wall of gas. The steam that appears to rise from the celestial mountains is actually hot ionized gas and hot dust streaming away from the nebula as a result of the nebula's constant radiation. The JWST reveals newly formed stellar nurseries and individual stars that were previously hidden in visible light images. Webb's sensitivity to infrared light allows it to see these objects through cosmic dust. Some of these young stars emit protostellar jets, which are visible in this image. The newest sources appear as red dots in the cloud's dark, dusty region. At number 2 is the JWST's image that depicts the beginning of a star's evolution. Thanks to the JWST, we now have previously unknown details about the dark cloud L1527 and its protostar, giving us insights into how new stars develop. These blazing clouds in the Taurus star-forming region can only be seen in infrared light, making them an excellent target for JWST's near-infrared camera or NIRCam. The protostar is concealed within the neck of this hourglass shape, and a dark line across the middle of the neck indicates an edge-on protoplanetary disk. The protostar's light leaks above and below the disk, illuminating cavities in the surrounding gas and dust. The clouds, colored blue and orange in this representative color infrared image, outline cavities formed as material shoots away from the protostar and collides with surrounding matter. The colors are caused by dust layers between JWST and the clouds. Webb also discovered shocked filaments of molecular hydrogen as the protostar ejects material away from it. Shocks and turbulence prevent new stars from forming, which would otherwise occur throughout the cloud. As a result, the protostar dominates space, absorbing much of the material. Despite how chaotic L1527 looks, it's only about 100,000 years old, meaning it's a relatively young body. L1527 is classified as a Class 0 protostar, the earliest stage of star formation, based on its age and brightness in infrared light as observed by missions such as the Infrared Astronomical Satellite. These protostars, which are still cocooned in a dark cloud of dust and gas, have a long way to go before they can be called stars. L1527 does not yet generate its own energy through the nuclear fusion of hydrogen, which is a necessary feature of stars. Its shape, while mostly spherical, is also unstable, resembling a small, hot and puffy clump of gas weighing between 20 and 40% the mass of our Sun. And number 3 is a picture that already existed but which the JWST made even more stunning. The Pillars of Creation, an iconic image first taken by Hubble in 1995 and even retaken in 2014. Still, nothing prepared NASA scientists for the rendering of the same space object by the JWST. What you see appearing like fingers are gas and dust-filled pillars enveloping stars that have been slowly forming over millennia. JWST captured this eerie, extremely dusty view of the pillars of creation in mid-infrared light, providing us with a new perspective on an old landscape. But why does mid-infrared light create such a dark, eerie atmosphere in Webb's mid-infrared instrument MIRI image? The scene is shrouded in interstellar dust. While mid-infrared light is great for detecting dust, the stars aren't bright enough at these wavelengths to be visible. Instead, the edges of these looming, laden-hued pillars of gas and dust gleam, hinting at the activity within. This region has produced tens of thousands of stars. However, interestingly, the majority of the stars are missing. Why? Many newly formed stars have lost too much dust to be detected in mid-infrared light. MIRI instead observes young stars who have yet to shed their dusty cloaks. These are crimson orbs near the pillar's edges. The blue stars that dot the scene, on the other hand, are aging, which means they have shed most of their layers of gas and dust. Mid-infrared light is particularly good at observing gas and dust in great detail. This is also evident throughout the background. The darkest shades of grey are found in the densest areas of dust. The dust is diffuse and cooler in the red region toward the top, which forms an uncanny V like an owl with outstretched wings. There are no background galaxies visible because the interstellar medium in the densest part of the Milky Way's disk is too dense with gas and dust to allow their distant light to penetrate. And for context, the spot captured in this photo is about 6,500 light-years away. Exoplanets are becoming more popular, and at number 4 is the image of one taken by the JWST showing unprecedented details of the atmosphere. JWST was trained on the atmosphere of WASP-39b exoplanet, and it didn't disappoint. In fact, the $10 billion telescope just scored another first, a molecular and chemical profile of a distant world's skies. While Webb and other space telescopes such as NASA's Hubble and Spitzer have previously revealed isolated components of this scorching planet's atmosphere, the new JWST readings provide a full menu of atoms, molecules, and even signs of active chemistry and clouds. The most recent data also shows how these clouds might appear up close, broken up rather than a single uniform blanket covering the planet. The telescope's array of highly sensitive instruments was trained on the atmosphere of WASP-39b, a hot Saturn, or a planet roughly the size of Saturn but in a tighter orbit than Mercury, orbiting a star 700 light-years away. The findings bode well for the capability of JWST's instruments to conduct the broad range of investigations of all types of exoplanets hoped for by the science community. That includes probing the atmosphere of smaller rocky planets like those in the TRAPPIST-1 system. This is the first time scientists see concrete evidence of photochemistry or chemical reactions initiated by energetic stellar light on exoplanets, making the outcome a huge deal. This led to another first: scientists applying photochemistry computer models to data that requires such physics to be fully explained. The resulting improvements in modeling will aid in the development of future technological know-how for interpreting potential signs of habitability. The planet's proximity to its host star, 8 times closer than Mercury is to our Sun, also makes it an ideal laboratory for studying the effects of host star radiation on exoplanets. And number 5 is the image of a lonely galaxy captured by the JWST. The most capable space telescope currently in use has focused on a lone dwarf galaxy in our local region of space and captured amazing images of it. The Wolf-Lundmark-Melotte, or WLM dwarf galaxy, is named after the 3 astronomers who were instrumental in its discovery and is located about 3 million light-years from Earth. It is close enough for the JWST to be able to distinguish individual stars while still being able to study many stars at once. One of the most distant members of the local galaxy group that includes our galaxy is this dwarf galaxy, which is located in the Cetus constellation. WLM is helpful in the study of how stars evolve in smaller galaxies due to its isolation and lack of interactions with other galaxies, including the Milky Way. According to a statement from the Space Telescope Science Institute in Maryland, which runs the observatory, WLM hasn't interacted with other systems, which makes it really nice for testing out theories of galaxy formation and evolution. It is more difficult to investigate many of the other nearby galaxies because of how they are entangled and interwoven with the Milky Way. Another reason WLM is an intriguing target is that its gas is very similar to that of galaxies in the early universe, with no elements heavier than hydrogen and helium. However, unlike the gas in those early galaxies, the gas in WLM has lost its share of these elements due to a phenomenon known as galactic winds. These winds are caused by supernovas or exploding stars. Because WLM is so small, these winds can push material out of the dwarf galaxy. The image contains an array of individual stars at various stages of evolution, with a variety of colors, sizes, temperatures, and ages in the JWST image of WLM. The image also depicts clouds of molecular gas and dust, known as nebulas. At number 6 is the image containing an effect caused by a rare type of star and its companion locked in a celestial gyration. A new image from NASA's James Webb Space Telescope shows at least 17 concentric dust rings emanating from a pair of stars named Wolf-Rayet 140. This is a pair of stars located just over 5,000 light-years from Earth. When the two stars approached each other, their stellar winds, streams of gas they blow into space, collided, compressing the gas and forming dust. The stars' orbits bring them together about once every 8 years. The dust loops, like the growth of rings on a tree's trunk, mark the passage of time. We're basically looking at over a century of dust production from this system. The image also shows how sensitive the JWST is. Previously, astronomers could only see 2 dust rings using ground-based telescopes. We now have at least 17 of them. In addition to Webb's overall sensitivity, its MIRI is uniquely qualified to study dust rings, also known as shells because they are thicker and wider than they appear in the image. JWST's scientific instruments detect infrared light, which has wavelengths that are invisible to the human eye. MIRI detects the longest infrared wavelengths, allowing it to see cooler objects such as dust rings than Webb's other instruments. MIRI's spectrometer also revealed the dust's composition, which was mostly made up of material ejected by a specific type of meteor. A Wolf-Rayet star is a dying O-type star with at least 25 times the mass of our Sun that is on the verge of collapsing and forming a black hole. A Wolf-Rayet star, which is burning hotter than it was in its youth, generates powerful winds that propel massive amounts of gas into space. This process may have resulted in the Wolf-Rayet star in this pair losing more than half of its original mass. At number 7 is the JWST's image showing incredibly faint, ghostly light emitted between galaxies. JWST observed intracluster light, ICL, which is the very faint emission produced by stars being dragged out of their galaxies as these cosmic islands interact within a cluster. The discovery of this light has far-reaching implications not only for understanding the evolution of galaxies and galaxy clusters, but also for a mystery central to our overall understanding of the universe. JWST's Deep Field image of SMACS J0723373727 was the Space Observatory's first science observation. It has incredible sharpness and is twice as deep as what we can see with Hubble. Because JWST sees the universe in infrared light, the observations enable the study of galaxies that are much more distant. The light of distant galaxies is stretched and pushed towards redder wavelengths as the universe expands, a phenomenon similar to the Doppler shift we can hear from, say, a passing ambulance, where the pitch changes depending on whether it's approaching or moving away from you. This image shows the great potential of JWST for observing faint objects. It will allow scientists to study galaxy clusters that are much further away in greater detail. While JWST is fantastic, this light is still extremely faint, and the galaxies in the cluster are extremely bright, so observations alone will not suffice. It also necessitates techniques for analyzing the observations in such a way that the emissions can be distinguished from the brighter sources in the image. The information gathered provides a picture of how the galaxy cluster is evolving. At number 8 is a stunning image of rings that JWST took in its own backyard. Neptune lurks in one of our solar system's darkest regions. The planet has long perplexed astronomers with its complex rings, strange moon, Triton, and roaring winds faster than the speed of sound on Earth. Only one spacecraft, Voyager 2, has ever visited this distant planet, and observations from both space and ground-based telescopes have tracked the many turbulent storms over the years. The first look at this ice giant by JWST provides a long-awaited glimpse of those crisp rings as well as details on its mysterious storms. With its first image of Neptune, the JWST demonstrates its capabilities closer to home. JWST's cameras not only captured the clearest view of this distant planet's rings in more than 30 years, but they also revealed the ice giant in a completely new light. The crisp view of the planet's rings, some of which have not been detected since NASA's Voyager 2 became the first spacecraft to observe Neptune during its flyby in 1989, is the most striking feature of Webb's new image. The Webb image clearly shows Neptune's fainter dust bands in addition to several bright, narrow rings. We haven't seen those faint, dusty bands in 3 decades, and this is the first time we've seen them in infrared. Neptune orbits in the remote, dark region of the outer solar system, 30 times farther from the Sun than Earth. The Sun is so small and faint at that extreme distance that high noon on Neptune is comparable to a dim twilight on Earth. At number 9 is the stunning picture that reminds you of spiders. There are no spiders in space, but the JWST has captured images of the Tarantula Nebula, also known as the 30 Doradus. Its name was derived from its resemblance to the spider itself, but in JWST's view, the entire region resembles a tarantula's home inside a burrow lined with its own spun silk. The Tarantula Nebula is home to thousands of young and still-forming stars, many of which Webb discovered for the first time. Working together, a variety of JWST's high-resolution infrared instruments reveal the star's structure and composition of the nebula with unprecedented detail. In fact, JWST will be used by astronomers throughout its mission to gain insight into star formation and the stellar life cycle, with implications for our own star, the Sun, as well as the formation of heavy chemical elements that are essential to life as we know it. The image contains thousands of never-before-seen young stars located in the stellar nursery 30 Doradus. The Tarantula Nebula has long been a favorite of astronomers studying star formation. JWST discovers distant background galaxies as well as the detailed structure and composition of the nebula's gas and dust. The Tarantula Nebula is the largest and brightest star-forming region in the local group of galaxies, which is only 161,000 light-years away in the Large Magellanic Cloud Galaxy. It is home to some of the hottest and most massive stars. At number 10 is the JWST's image of Pandora's cluster. The JWST has captured images of Pandora's cluster, Able 2744, using its NIRCam. The north and east compass arrows in the image indicate its orientation in the sky. It is worth noting that the relationship between north and east in the sky, as seen from below, is reversed in relation to direction arrows on a ground map as seen from above. The scale bar is labeled in arc seconds, which is an angular distance measurement of the sky. 1 arc second equals 1/36,000 of a degree arc. The angular diameter of the full moon is approximately 0.5 degrees. The actual size of an object that spans 1 arc second across the sky is determined by its distance from the telescope. This image depicts invisible near-infrared light wavelengths that have been converted into visible light colors. The color key indicates which NIRCam filters were used to collect the light. Each filter is named after the visible light color that is used to represent the infrared light that passes through it. However, the images contain some other interesting details. They show 2 of the most distant galaxies ever seen. The galaxies are billions of light years behind the cluster, not within it. The galaxy in the top center image was extracted from the image on the left. It was only 450 million years after the Big Bang that it existed. The galaxy in the bottom center image was extracted from the image on the right. It predated the Big Bang by 350 million years. Both galaxies can be found very close to the Big Bang, which occurred 13.8 billion years ago. These galaxies are tiny in comparison to our Milky Way, with only a few billion stars. At number 11 is the image of the heart of the Phantom Galaxy. The heart of M74, also known as the Phantom Galaxy, is depicted in this image from the JWST. The telescope's keen eyes revealed delicate filaments of gas and dust in the grandiose spiral arms that wind outwards from the image's center. The lack of gas in the nuclear region also allows for a clear view of the nuclear star cluster at the galaxy's core. M74 is a grand design spiral, which means that its spiral arms are prominent and well-defined, as opposed to the patchy and ragged structure seen in some spiral galaxies. The Phantom Galaxy is located 32 million light-years from Earth in the constellation Pisces, almost face-on to Earth. This, along with its well-defined spiral arms, makes it a popular target for astronomers researching the origin and structure of galactic spirals. JWST used its MIRI to study M74 in order to learn more about the early stages of star formation in the local universe. These observations are part of the International FANGS Collaboration's larger effort to map 19 nearby star-forming galaxies in the infrared. The Hubble Space Telescope and ground-based observatories have already observed these galaxies, but the addition of crystal-clear Webb observations at longer wavelengths will allow astronomers to pinpoint star-forming regions in galaxies, accurately measure the masses and ages of star clusters, and gain insight into the nature of small grains of dust drifting in interstellar space. At number 12 is the image of the JWST showing the stellar gymnastics of the Cartwheel Galaxy. A lot is going on inside the Cartwheel Galaxy, and the JWST has finally given us a peek into the large-scale chaos up there. The Cartwheel Galaxy, located in the Sculptor constellation about 500 million light-years away, is a rare sight. Its appearance, similar to that of a wagon wheel, is the result of a high-speed collision between a large spiral galaxy and a smaller galaxy not visible in this image. Collisions of galactic proportions set off a chain reaction of smaller events between the galaxies involved, and the Cartwheel is no exception. The collision had the greatest impact on the galaxy's shape and structure. The Cartwheel Galaxy has two rings, a bright inner ring and a colorful outer ring. These two rings spread outward from the collision center like ripples in a pond after a stone is thrown into it. At number 13 is the image of a quasar that shows the dense cosmic knot in the early universe. Astronomers studying the early universe with JWST have made an unexpected discovery, a cluster of massive galaxies forming around an extremely red quasar. They said the findings will help us better understand how galaxy clusters in the early universe came together to form the cosmic web we see today. A quasar is a type of active galactic nucleus, or AGN, that is a compact region at the center of a galaxy with a supermassive black hole. The quasar is illuminated by gas falling into a supermassive black hole, making it brighter than all the stars in the galaxy. JWST discovered the quasar SDSS J16520264172853, which was formed 11.5 billion years ago. It is unusually red not only because of its intrinsic red color, but also because the light from the galaxy has been redshifted due to its great distance. Because of its unparalleled sensitivity in infrared wavelengths, JWST was perfectly suited to examine the galaxy in detail. At number 14 is JWST's image of a pair of galaxies first previewed by VP Kamala Harris and French President Macron. In this image is merging galaxies. This pair of galaxies, known as IIZW96, was first shown to Vice President Kamala Harris and French President Emmanuel Macron during a visit to NASA headquarters in Washington. IIZW96 is approximately 500 million light-years from Earth and is located near the celestial equator in the constellation Delphinus. Aside from the wild swirl of the merging galaxies, the image also contains a slew of background galaxies. The two galaxies are merging, and the result is a chaotic, disturbed shape. The two galaxies' bright cores are linked by bright tendrils of star-forming regions, and the lower galaxy's spiral arms have been twisted out of shape by the gravitational perturbation of the galaxy merger. These star-forming regions are what attracted JWST to IIZW96. The galaxy pair is especially bright at infrared wavelengths due to the presence of the star formation, with luminosities exceeding 100 billion times that of the Sun. Webb photographed this merging galaxy pair using 2 of its cutting-edge cameras. At number 15 is a stunning image of a galaxy pair obtained by merging the JWST and Hubble. The Hubble used to be the top space telescope. Scientists still have uses for it and were able to trace light emitted by the largely white elliptical galaxy on the left through the spiral galaxy on the right and identify the effects of interstellar dust in the spiral galaxy by combining data from the JWST and the Hubble Space Telescope. It uses the near-infrared light of the former and the ultraviolet and visible light of the latter to capture the galaxy pair VV191. JWST's near-infrared data also reveal far more detail about the galaxy's longer, extremely dusty spiral arms, which appear to overlap with the central bulge of the bright white elliptical galaxy on the left. Although the 2 foreground galaxies are astronomically close, they are not actively interacting. Let's hear your favorite of all the images from the JWST so far in the comments section below.